You are here because of geology, and you should take that message home with you. You see behind me Jötfjellet. You would see it if you come back in summer. Now it's Polar Night Week, not Polar Light Week. But of course, it's the coal mining which has given us Longyearbyen. Probably the oil industry has given us UNIS and everything else with the income. But I think it's quite important to know that there is a lot of societal relevance here of geology. We have been drilling for CO2 storage here locally, but these drill cores have also given us insights into how the climate changed in the geologic past. It has also given us insights into how the geologic timescale itself has changed. And the geosphere has often been lacking a bit in the science community, so together with Fenna and 27 co-authors, in addition to us two, all around the world, we put together a review of the Svalbard geology, which was a great experience for us and hopefully also give us some more platform to collaborate with the other spheres. So I'd like to just give Fenna the opportunity to present some of the highlights.
Yes, thank you, Kim. So indeed, what Kim said before, the geology in Svalbard is all around us if we look at the surface expressions. But these are actually formed by processes happening deep in the earth, hundreds of kilometers under our feet, in the crust and in the mantle. So that was one of the highlights of our report, to look at how do these deep processes work. But we don't just look deep into the earth as geologists, we also look deep into time. So behind us you see Jötfjellet, and it goes back about 100 million years, but actually the rocks of Svalbard contain the climatic history of 500 million years. So by studying that history, we can actually figure out a lot about what happened in the past, mass extinctions, but also how did all the different spheres, the hydrosphere, the atmosphere, interact before the human influence. So it's pretty important to do the geology work, but as you can imagine, it's also pretty complex, deep into earth, deep into time, so we really need to integrate a lot of different data sources. So you have geologists who are drilling to get subsurface data, who are flying drones to do the remote sensing. And in that way, we try to get a lot of different puzzle pieces, combine it all to better understand what's going on. And understanding the past is very important for understanding what's happening right now, but also for being able to predict what's going to happen in the future. We're living in a time of climate change, so then it's important to understand how did that affect the Earth before, so better predict how it might affect the Arctic, especially in the future. So that was the main importance of geology.